Okay, guys, this is section 4.2. We're solving inequalities using addition or subtraction. I'm going to be frank, this is easy. It's basically, we're going to treat this like a normal equation and how to solve for the variable via SADMAP. So just to kind of give you something really simple, if I were to give you an equation, x plus 3 is equal to 5, your job is to solve for x. So how do you do that? We subtract 3, and we do that on both sides. So what do we get? X is equal to the number 2. So we're literally going to be doing the same type of thing, but we're going to be using our inequalities and our inequality symbols, all right? So nothing overly complicated in that point. Next video, we'll go a little bit more detail with an extra step, but let's just go with this thing. All right, so if this very first problem, I have y minus 3 is greater than or equal to a negative 12. So how do we go about solving this? Well, like I said, we just treat it like a normal equation. So just like before, I need to get y by itself, so I use SADMAP and I get rid of the minus by adding 3 to both sides. When I do, that cancels out and that leaves me with y is greater than or equal to, and let's find out what a negative 12 plus 3 is, and that's pretty easy actually. We can say that that's going to be negative 9. Now my job is to simply graph it. So just like in the last video, I'm going to put negative 9 right in the middle, and because this is a greater than or equals to, I am going to put a solid dot there. And because it says that y is greater than that means that all the numbers to the right, no matter what they are, will be my answer. All right, let's do another one. I have negative 14 is less than or equal to 8 plus x. So same concept, I need to get x by itself. So just like we did with before, we're not looking at this right here as a plus, and even though that's true, we need to look at the number 8. This number 8 is a positive. It is a positive, so to get rid of it, we have to subtract 8 from both sides. When we do, negative 14 minus 8 will give me a negative 22 is less than or equal to, and the 8 and the negative 8 cancel out, and I get x. So negative 22 is less than x. So what I do is I'm going to put negative 22 right in the middle, and since it says or equals to, I'm going to put a solid dot. And now let's look at it. It says that negative 22 is less than or equal to x. If I were to rethink this through, it means that x is the bigger thing. So I'm going to have to pick which side this is. And it's kind of counterintuitive when we look at this, but remember, x is bigger. So if you get confused, always put this down. So let's say we know this to be negative 23, we put this to be negative 21. If we were to put these numbers in there, negative 22 is less than or equal to a negative 23, is this a true statement? No, it's not. How about now? Negative 22 is less than or equal to a negative 21. Whoops, 21. Is that a true statement? Yes, it is. That means in this case, I'm going to draw my arrow this way because it's less than or equal to all of these x's. All right, and that's kind of it. I mean, I'm not even going to waste your time making a longer video on this. What I do want you to do is try number 3, number 4, number 5, and 6 on your own, and we'll look at 7 together here in just a second. But go ahead and try these out and see what you do. All right, so what you should have gotten for the first one is t is less than 0. That's not the first one, but number 3. The next one you would have gotten negative 11 is greater than or equal to d. The next one you would have gotten negative 2.2 is greater than c. That's not a very good symbol. Let's rewrite that. Greater than c. And then lastly, you would have got j is less than or negative 7.6. All right, so again, this should not be that difficult. You've got your calculator to help you out with the fractions and decimals. Shouldn't be a problem. Let's just look at number 7, though, before I let you be. Wow. Let's see. A bounce house can hold 15 children. 7 children go into the bounce house. Write and solve an inequality that represents the additional number of children that can go into the bounce house. All right, so We know that the bounce house can hold 15, and it can't hold any more than that. And listen to what I said. It cannot hold any more. So it has to be bigger than that number. It can be equal to 15, but it cannot be bigger than 15. So it cannot hold any more than 15. Now, we know that 7 children have gone into the house, because that's what it says so. And then it says, write and solve an inequality that represents the additional children that can go. So we know this, that there's 7 in there right now, and we can add an X amount of people, but it cannot be any more than 15. Now that I've done that, it's just a matter of solving by subtracting 7 on both sides. And when I do, I get that 8 is greater than or equal to 6. So in other words, when I look at this, I can say that 1 person can go in, 2, 3, 4 people can go in, 5, 6, 7 people can go in. I can even have 8 people to go into that bounce house, but I cannot have any more, because if I do, that means I go over that 15 person limit that's on here. All right, so that's pretty much the end of this video. Again, it's pretty simple. You know how to find me if you got some questions, and I'll see you in the next video. Bye-bye.